Well, good morning, everyone, and welcome to the second instalment of our Smart Construction webinar series. My name is Matthew Fleming. I'm the Technology Advisor for Queensland, and today I'm going to take you through what our intelligent machine control technology is and how its integration into our customers' businesses creates improvements in efficiency and cost reduction, and also addresses the skilled labour shortage in the industry. So there's no distraction during the presentation. I'll be turning the camera off, and we'll turn it back on during the questions and answers at the end of the session. I've been with Komatsu since 2005, and all of the various roles I've held within the company, being a technology advisor and dealing with the state-of-the-art systems is by far the most satisfying. I found it really fascinating, and I'm enjoying the challenge of helping customers learn about the iMC's many advantages. In this webinar, we'll be taking a brief look back at our 1.0 machines and the technology they utilise. We will then dive into what's new with our 2.0 machines and their technology, and also talk about what it all means for customers using GPS-grade control systems, followed by some Q&A. Firstly, I think to gain an understanding of our current technology, it's important to have some background knowledge on where we've come from. So let's look at our iMC 1.0 machines, the first iteration for intelligent machine control, and the technology they've utilised over the past 7 years. Komatsu's original range of iMC bulldozers and excavators were an industry-leading first for not only safety and security, but efficiency and cost saving as well. Starting with our bulldozer range, which you'll find on most civil construction sites, and beginning with the smallest bulldozer in our iMC range, the D61 EXI and PXI-23, an excellent trimming bulldozer. This bulldozer has an operating weight between 17.8 tonne to 20.5 tonne, and a pat blade or power angle tilt blade, and an engine output of 168 horsepower. Next in our lineup is the D65 EXI and PXI-18, with an operating weight between 20.7 tonne to 24.2 tonne, a pat blade, or the option for a blade and push arm style work equipment setup, as per the D85 and 155, and an engine output of 217 horsepower. Then we have the D85 EXI and PXI-18, with an operating weight between 30.5 tonne to 32 tonne, a blade and push arm style work equipment setup, and an engine output of 264 horsepower. And finally, we have the D155 EXI and PXI-8, which is used for bulk earth moving works with an ability to trim to a design and an operating weight of 32.7 tonne to 42.4 tonne, a blade and push arm style work equipment setup, and an engine output of 354 horsepower. These models were all released into the Australian market between 2015 and 2016. The technology utilised in the 1.0 bulldozers was a single cab-top mounted GNSS or Global Navigation Satellite System antenna, responsible for receiving satellite signals in order to position the machine on the job site in relative coordinates. A chassis-mounted IMU or inertial measuring unit sensor, which along with intelligent logic, orientates the body of the machine underneath the antenna, either sloped or flat. Hydraulic cylinders with factory integrated stroke sensors monitoring the lift, tilt, and angle of the blade, allowing the machine control system to know the exact position of the blade at any given time. A factory installed touchscreen control box, allowing easy operator access to set or adjust design surfaces and to display GNSS satellite information. 4 working modes, which determine how the blade reacts to loads, which are cutting and carrying for long, shallow cuts or normal dozing operations, cutting for short-range cutting operation, spreading for the spreading operation of soil piled higher than the height of the blade, and simple grading used to carry out final trim or slope and batter work. And lastly, 3 intuitive blade load settings, selectable depending on the desired response to the given material conditions. For example, dry sandy material might call for a light load setting, whereas a heavy clay type material would call for a heavy load setting. Looking at our excavator range, which started off with the PC210 LCI-10, released to the Australian market in 2016, with an operating weight of 22.6 tonne to 23.8 tonne, and an engine output of 158 horsepower. Followed by the PC360 LCI-11 in 2018, with an operating weight of 35.9 tonne to 37.4 tonne, and an engine output of 257 horsepower. Both of Komatsu's 1.0 excavators utilise the same technology, which includes stroke sensing hydraulic cylinders with factory integrated sensors to monitor boom, arm, and bucket positioning, allowing the control system to know the exact position of the bucket cutting edge at all times. An IMU, or inertial measuring unit, that monitors the pitch and roll of the machine in order to produce highly accurate finishing work. 2 GNSS antennas responsible for receiving satellite signals and sending them to a GNSS controller in order to accurately position the machine on the job site. A large 12-inch monitor allowing excellent visibility and ease of use with a touchscreen icon interface instead of a multi-step menu to simplify operations. A unique facing angle compass, which indicates the angle of the bucket in relation to the target surface. This assists the operator to accurately position the bucket edge square to the target surface. An auto grade assist function for the arm movement, auto stop control function for the boom and bucket movement, and minimum distance control for the bucket edge, all of which we will go through in more detail when we look at the 2.0 excavators shortly. So secondly, let's talk about the iMC 2.0 machines. When iMC 1.0 came on the scene, the benefits were all around increasing ease of operation and productivity. Komatsu's 2.0 machines are all about building on those features. Let's take a look at what is new with these machines and their technology, starting once again with our range of iMC bulldozers. If we look once again at Komatsu's D61 EXI and PXI bulldozer, it is now reclassed as a -24 with an operating weight of 18.6 tonne to 19.5 tonne. The engine output remains the same at 168 horsepower, and the improved 2.0 range starts at machines with a serial number of 45,000 and up. Next, the D65 EXI and PXI-18. It now has an operating weight of 23.3 tonne to 24.2 tonne. The engine output remains at 217 horsepower, and the 2.0 range starts at machines with a serial number of 96,001 and up. Last year, Komatsu introduced the all-new D71 EXI and PXI-24 into the Australian market. Our largest HST, or hydrostatic transmission type bulldozer. This bulldozer has an operating weight of 22.7 to 24 tonne and an engine output of 240 horsepower. Finally, in our 2.0 bulldozer range, we have the D85 EXI and PXI-18 with an operating weight of 29.7 tonne to 31 tonne and an engine output of 264 horsepower, with the new 2.0 range starting at machines with a serial number of 25,005 and up. Unfortunately, the D155 didn't get a 2.0 update this time around, but I'm sure it'll be in the plan to have it upgraded soon. Looking at the technology utilised on the 2.0 bulldozers, Komatsu's 2.0 bulldozers have dual multi-constellation GNSS antennas, which means that they can receive positioning information from American, Russian, Chinese, European, and Japanese satellites, whereas our 1.0 bulldozers will only receive signals from American and Russian satellites. This enables the machine to have high positioning accuracy due to an increase in satellite availability. Also, as the antennas are mounted to the top of the cab, they are less likely to require replacement due to damage or theft, as some pole-mounted variants may be. The dual antenna setup also allows the machine to immediately know which way it's facing or its orientation, making slope work more efficient. All of Komatsu's iMC bulldozers have the auto and manual switch located at the front of the work equipment lever, allowing the operator quick access to the auto function at any time. Cut, fill, offset switches are conveniently located just to the right of the work equipment lever, giving the operator the ability to adjust the target surface height without having to touch the control box. On the same panel as the cut and fill switches is the industry-first backgrade mode switch, which allows for automatic control during backgrading, which is perfect for removing those deep track plate marks during final trim application. And the easy-to-use touchscreen display features bright graphics and customizable views with a mount that allows the viewing angle to be adjusted to the operator's preference. With the quick surface creation function, the operator can now create temporary design surfaces such as flat or sloping planes with one press of a button, where previously this required cycling through various menus or, many years ago, having to wait for a simple design from a surveyor or designer. Now the operator just needs to put the blade on the ground, press the shortcut button, set the main fall and cross fall, and start pushing dirt. You can now double production with the new lift layer control function. With the press of a button, the bulldozer automatically spreads fill to a consistent layer height by measuring the terrain it tracks over and using that data to plan the next pass. Excess fill is also eliminated, as automatic blade control will follow the finished surface once layers have reached finished grade. Now I want to talk about the automatic tilt steering control in the 2.0 update. With one press of a button, the bulldozer will automatically and continuously tilt the blade when a heading deviation is sensed. This works in part because of the dual GNSS antenna system on the 2.0 iMC bulldozers. Due to the accuracy in the heading now, the system knows when the machine is deviating from a straight travel direction, normally caused by an uneven load on the blade during cut and carry operations. The system moves to correct this deviation by automatically tilting one edge of the blade into the ground, which steers the dozer back into the required heading. Because the system knows where the blade edges are in relation to the design surface, it will not allow the blade to cut through the finished surface level at any time. This function allows steering input by the operator to be reduced by up to 80%, decreasing operator fatigue and increasing productivity due to straighter, cleaner cuts. Utilizing the blade to turn the machine also alleviates overheating of the hydraulic and transmission system, which is normally due to constant operation of the steering during cut and carry operations. New 2.0 bulldozers now have proactive dozing control, which utilizes the latest as-built or as-constructed data to perform cutting and carrying operations. Think of as-built data as positional information that the machine records as it's cutting or filling a design. That information is then strung together to create a picture of the newly cut surface, and this happens every time the bulldozer moves over the terrain. A vertical adjustment or offset is applied, usually no more than 200 millimeters in depth, depending on the load setting from the operator, and the bulldozer now has a plan for the next cut. This allows the bulldozer to minimize undulation and undercut, and in addition, facilitates more smoother and efficient dozing operations, as if it were being performed by an expert operator, promoting less operator fatigue, leading to more productivity and safety. Taking a look at the top diagram on the left-hand side, we see the old technology in use, showing the blade is not capable of following the current surface when in a cut and fill operation. In the bottom diagram, we see proactive dozing control in use, with the blade following the current surface, allowing for more efficient and smooth operations due to the blade being able to push for longer periods with less requirement to reverse back to load the blade again. Automatic mode also allows the operator to manually adjust the blade cutting height while auto is engaged to make the digging depth a little deeper or shallower depending on the operator's requirements. Similarly, if the current ground conditions differ excessively from the finished design surface, the tilt angle of the blade can be adjusted manually and the automatic mode will still prevent the blade from overdigging. This gives the operator the flexibility to adapt to any job site while using auto mode. So what does it mean for bulldozers? Well, traditionally, before any machines could move dirt, there was extensive preparation required, sometimes involving many hours of placing wooden stakes in the ground by surveyors to indicate the different finished surface levels within a project. Not only was the initial staking out time-consuming role, but when a stake was run over or moved accidentally by a machine, the surveyor then had to go back out and remeasure and restake. So this made construction work inefficient, costly, and also because of the need to be working around moving machinery to check the accuracy of the work, it was unsafe. When machine control came onto the scene, there was a 41% overall reduction in the time taken to create a surface from a set design, and this was mainly due to the staking process being made redundant. So how was such an integral process made redundant? Well, when a 3D design is created for machine control, it provides positional information for every line or surface in that design. So when the machine is done cutting a design to its finished surface level, there is no longer a need for staking out or to carry out grade checks. Komatsu's iMC product improves by an average of 13% on that overall time reduction due to the functionality of our bulldozer work modes. Conventional bulldozer machine control is concerned only with the finished surface level or blade position. As in the top diagram, when the bulldozer moves forward, the blade cuts into the ground. The load on the blade increases to a point where the tracks start to slip. This slippage can cause damage to the target surface. It decreases forward movement and creates an uneven surface finish requiring blade lever input from the operator, and it makes the bulldozing operation inefficient. In the bottom diagram, we see Komatsu's iMC bulldozer system is not only looking at the blade position, but also blade load and track slippage. When an iMC bulldozer moves forward and the blade cuts into the ground, the GNSS system looks at the speed of the track motors and the GNSS speed and calculates any difference. If the difference is too great, the system classes this as track slippage. At this point, the blade will automatically lift to reduce the load on the blade so the machine can continue to move forward. This creates a smooth, stable surface finish, allows forward movement to continue, and with less blade lever operation required by the operator, makes the bulldozer operation more efficient. Now to take a look at the 2.0 excavator range. And we start with the PC210 LCI-11 with an operating weight of 23 tonne to 23.8 tonne and an engine output of 165 horsepower. Then we step up to the new PC290-11 with an operating weight of 29.8 tonne to 31.2 tonne and an engine output of 213 horsepower. And currently, the biggest excavator in our iMC 2.0 range is the PC360LC-11 with an operating weight of 35.9 tonne to 37.4 tonne with an engine output of 271 horsepower. Now let's look at the technology that has gone into the 2.0 excavators. The new excavators now have a more compact profile 10.4-inch monitor screen or control box. The control box is not only a monitor so the operator can see where he is in relation to the design, but it also figures out the position and direction of the machine by calculating the positional relationship of each multi-GNSS antenna. The control box works out the coordinates of the current bucket blade edge by calculating the machine position, machine direction, work equipment posture, machine pitch angle, and machine roll angle. The control box also figures out the distance the bucket cutting edge is from the finished surface design by calculating the target bucket blade edge coordinates and comparing them to the actual bucket blade edge coordinates. As with our new range of bulldozers, the excavators have two multi-constellation GNSS antennas, allowing positioning information from American, Russian, Chinese, European, and Japanese satellites, enabling the machines to have high positioning accuracy due to an increase in satellite availability. 2.0 excavators utilize an IMU sensor on either a tilt hitch or a tilt bucket setup, allowing for auto tilt control. Our new excavators use an updated GNSS controller with a combined 4G modem installed, reducing the number of components in the cab compared to the previous model. There is an IMU on the upper structure that determines the pitch and roll of the machine and communicates this to the control box in order to produce highly accurate finishing work. Our hydraulic cylinders utilize factory integrated sensors to monitor boom, arm, and bucket position, allowing the control system to know the exact position of the bucket cutting edge at all times. And the semi-auto and manual switch design surface offset function and manual tilt function can all be operated with switches on the new proportional control levers. The new machine control functions included in our 2.0 iMC excavator technology are the bucket angle hold control, in which the system automatically maintains the operator set bucket angle throughout the entire grading pass, the auto tilt attachment control, which automatically tilts the bucket to the design surface and returns it to horizontal for unloading, minimum distance control, which automatically selects the bucket point closest to the surface, auto stop control, which prevents the bucket edge digging through the finished design surface, and auto grade assist, which allows the boom to automatically adjust the bucket height. These new additions to the iMC excavator system improve the work efficiency, allowing less skilled operators to carry out work usually performed by more experienced operators. With the bucket angle hold feature, when the operator places the bucket on the design surface and operates the arm lever, either in or out, the 2.0 excavator system will keep the bucket at that angle as the arm moves, improving the final grade accuracy and increasing ease of operation. If we look at the animation on the right side of the screen, we can see what this would look like as the operator moves the arm both towards the machine and away from the machine. This function can be overridden by the operator at any point during operation or can simply be turned off if not required. Komatsu's new auto tilt attachment function will automatically match the bucket angle with the design of the slope when the bucket is operated within 200 millimeters of the design surface, whilst using the auto function with minimum distance control. And will also automatically return the bucket to a flat position for unloading when the bucket is moved away from the design surface. If we take a look at the animation on the right of the screen, we can see what it would look like when the auto tilt function takes effect. The dotted line represents the design's finished surface level. This feature simplifies complex grading tasks while improving the grading accuracy of inexperienced operators and at the same time reducing operator fatigue. Maintaining grade accuracy over extended periods of time decreases the possibility of rework and therefore increases the efficiency of the operation and overall the business. Feedback from our customers indicated that the 1.0 tilt harness attachment connection was a stress point and that the M12 5-pin cable used was often damaged. For the 2.0 iMC excavator range, Komatsu moved the connection point for the IMU tilt sensor harness to the left-hand side of the arm and terminated the harness with an industry standard 4-pin Deutz connector, while providing a reinforced and protected connection area straight from factory. Komatsu's minimum distance control function allows the attachment's point of reference to be automatically selected based on which tip of the attachment is closest to the design surface. This minimizes the need for operator input, reducing fatigue, preventing rework, and increasing productivity. This function is critical for the auto stop control and auto tilt control functions in preventing over-excavation of the design surface. When operating the boom or bucket during semi-auto mode, Komatsu's auto stop control feature prevents over-excavation or damage to the design surface by automatically stopping the bucket tip when it reaches the finished surface level of the design. Looking at the animation on the right of the screen, we see the operator moving the boom towards the design surface, and then the boom stopping automatically as the bucket tip reaches the surface. A dotted line again representing the design finished surface level. This allows the operator to focus on other areas of operations rather than keeping an eye on the numbers on the control box for height and depth indication, as with guidance-only systems. This aids in allowing less experienced operators to work more accurately and efficiently, and therefore helping the business become more productive. When the operator moves the arm while digging in semi-auto mode, the auto grade assist function maintains the attachment's position above the design grade through each pass by raising the boom automatically to match the operator's input for the arm or the combined input of arm and bucket. Looking at the animation on the right of the screen, we can see that as the operator carries out the trimming operations with the arm function, the boom is automatically rising. Also, as the arm starts to move past the vertical, the operator is utilizing his boom down lever in order to extend his working range. The auto grade assist function allows the operator to carry out rough digging work without worrying about over excavation. It also allows the operator to perform trimming work while only needing to operate the arm, and, if required, the operator can manually adjust the bucket angle to ensure the optimal trimming result. Komatsu's 2.0 iMC excavator range now gives the operator a greater choice in how they would like their attachments set up. Not only can they adjust the hydraulic oil flow rate supplied to the attachment, but operators are now able to change whether they want attachment 1 or 2 on the left lever or the right lever with a press of a button. Operators are also able to increase or decrease the surface offset without having to take their hands off the lever. So what do all the systems aim to do? What does it all mean? Well, Komatsu set both a sloping and trenching project for an inexperienced operator and an experienced operator. The results showed that when carrying out slope work, an experienced operator who had moved from an excavator that had no machine control to one that had machine guidance only, there was a 54% reduction in working hours required to complete the task. When that same operator moved from the excavator with machine guidance only to an iMC excavator, there was a further 23% reduction in working hours required to complete the project. When the novice operator carried out the slope work in an excavator with no machine control and then moved to one that had machine guidance only, there was only a 19% reduction in work hours required to complete the task, mainly due to the overall operational inexperience. But when that same novice operator moved to an iMC excavator, there was a 54% reduction in work hours in order to complete the project, that is. And when comparing the novice to the experienced operator, utilizing Komatsu's iMC system provides just a 31% difference in total work hours required to complete the task. When the same tests were carried out for the trenching project, the experienced operator had a 59% reduction when moving to the guidance-only excavator system, and a further 20% reduction when moving to an iMC excavator from the guidance-only system. When comparing the novice operator to the experienced one using an iMC excavator to complete the project, the novice operator took just 38% or 25 hours longer than the experienced operator to complete the task. Komatsu released their intelligent machine control products globally in 2013 in order to provide a solution for two major issues facing the construction industry at present. The first issue being the ever-increasing skills shortage, with a large portion of the skilled operators being over 55 and looking to retire. The construction industry is left with an extensive skilled labour shortage. With Komatsu's iMC systems, operators with less than 5 years seat time can now bridge the experience gap with operators that have been in the industry for 25 to 30 years. And by helping the operator become more efficient, the customer's business benefits through the increase in production. The second issue that Komatsu's intelligent machine control products were assisting to solve was the inefficient way that construction industry deals with its created data. In upcoming webinars, you'll learn how the as-built data created by Komatsu's iMC machines gets utilized in our web-based smart construction applications to make our customers' businesses benefit even more through efficiency and productivity. That brings us to the end of the webinar presentation. So I will hand back over to Anna for some questions from the viewers.
Kia ora, Matt. Thank you very much for that. If you can turn your camera on, that would be awesome. So we are going to move now into the Q&A session and begin answering the questions you have posted. If you want to submit, please still submit your questions in the questions panel. So our first question that I have here is, you mentioned in the presentation that the hydraulic cylinders have stroke sensors that were factory integrated. Where are they positioned?
Yeah, great question. Komatsu's iMC stroke sensors are actually situated at the end of the cylinder where the rod comes out. It's in a factory design and installed housing that allows for quick replacement of the sensor without removing or disassembling the cylinder in any way, which facilitates less downtime should the need arise.
Okay, cool. So the next question I've got here is, how was the accuracy maintained on both the Bulldozer and the excavator systems?
So there are a couple of parts to this answer. To begin with, every machine that comes into Australia is extensively calibrated and tested before it arrives on the customer's site. And then when it gets to the customer's site, the accuracy is also checked against the site project to ensure the machine is within specification. Also, every time the machine is switched on, a cylinder stroke reset is requested by the system, which advises the operator to move the work equipment to full extension and retraction in order for the system to relearn the cylinder stroke, ensuring consistent system accuracy.
Thanks for that. Another question I have here is, can you give a percentage increase of productivity or efficiency of an iMC dozer over a standard dozer?
Yeah, great question. Due to the technology utilized by Komatsu, our systems are realizing a 59% increase in efficiency.
Also, another one is, what safety benefits does the iMC deliver?
Yeah, good question. Making the staking process redundant has meant that there is no requirement for surveyors or other personnel, for that matter, to work closely in and around the machines while they're moving, making the machines, I guess, more safe, really. Yeah.
Another question I have here is, notice the GNSS antenna on the handrail. Will it be stable?
Certainly, yeah, certainly. The antennas that we, the handrails that we mount the antennas on are actually bolted quite securely to the top of the machine. Yeah, so there's minimal movement, if any.
Okay, perfect. So thank you very much. At the moment, that's all the questions that we have for today. Just to let everyone know that it's been recorded, and in the next, oh, actually, sorry, there's another one, is, what training is available for operators or companies post-sale?
So Komatsu provides operator training for their specifically iMC, if being that's what we're talking about today. Komatsu will provide after sale training for our for any customers operators. If they'd like to get in contact with us, we can certainly arrange for an operator trainer to come out and train their operators.
Okay, perfect. I'll finish again. That's all the questions that I've got. If you guys have any more questions, feel free to email us directly. You'll see the email from marketing that's come out. So yeah, feel free to do that. So as I said, it concludes our questions. Thank you everyone for attending, and we hope you enjoyed. An email will come out in 24 hours where you're able to access this recording. You'll also receive a survey on the presentation, and would really appreciate if you can give us your feedback. We'll also send out our new webinar that's happening on the 15th of September with Pat Munro, who is speaking on our iMC Dozers, and would love you to join us for that. So thank you everyone for joining, and we hope you have a great rest of your day.